Cool. My talk has some overlap with actually what Stefan in the coffee corner was talking about. It's like everything become a config. So it's a little bit how we at Konux start slowly to move everything in subsystems, Kconfig, so we can develop new products faster. About me, I'm engineer manager at Konux. I develop professionally firmware over 15 years, unprofessionally nearly 25 years. So I'm getting also quite old slowly, but yeah, it happens. And we have been, also I've been using Zephyr now for nearly 3 years, and before it was going from assembly to C to C++ to Rust, so all the things you can imagine for embedded. What we do at Konux, so our base product, which is a bit older, uses some bare metal C++, is a device which measures acceleration on a switch for predictive maintenance. 3 years ago, we wanted to build something new on a rail node. When you decided to use Nordic for it. When we wanted to have something with lower power, so we went with a Bluetooth technology with a gateway technology. So we had a Bluetooth plus gateway, everything developed with Zephyr because it was also a very recommended thing from Nordic. This project didn't work out, so we canceled it, but it was using like around about 2 years, which was where we learned a lot. But we had a lot of time pressure, so the code base is a mess. And then we started our new project, which is kind of a new generation of our main device. And while we started working on it, we had like 2-3 others ideas. So we have one small device idea prototype, which is very similar to the new device, and we have another one. So we have 2 devices developed parallel. Mainly what we're selling is a software as a service, so the device is only a small part of it, and there's a lot of predictive maintenance for waiver operations for, Deutsche Bahn. Hey, if you switch in a good condition, it says basically more or less yes or no, more insights. So we're working with them, but just telling them it's not in a good condition doesn't mean they can repair it because we don't have money and time. Initial firmware structure was a bit cleaned up, so we tried to have everything like in apps, and we had like lots of different apps there, like a main application. Then everyone who knows when you go to certification, you have to have some test modes. We had a test app and whatever. And then we already had like some ideas. We said, okay, we want to develop something new in the future with driver and models. But it happened quite fast that you had to copy and paste between like different sub-projects, because we had like our own GitHub project for the Bluetooth node and one for the gateway. And it was a bit of a mess, and we did not even clean it fully. So for the new project, we had a bit of time in between where we started to split about basically all our main ideas in the konux sensor, whatever repo. And then we have, which is not yet nicely cleaned up, but we have like sub-git models for models, then everything which is our boards and the drivers, and then we have our own models just for supporting scripts, because there's always things, you run, which nowadays, if I would do this thing, I would integrate it more into West. But when we started, West was not net nicely for all this stuff, and we have the things from our old project. And we have our communication for backend. We decided to go with protobuf. So we have a repo where just all the protobuf stuff is living. Yeah. So the most important game changer for us was with Zephyr model YAML, because even project which are not, let's say, really a Zephyr project, you can kind of add the Zephyr model. Maybe you add a little bit of a small CMake script explaining what it should build. So this is really nice. So we have our protobuf descriptor with the file with nanopp just for our device, but also we have the ones which are building it, some Python wrapper for the ones which has been running in RBS or even other languages. And kind of our shared library, which contains most of our models, the same. And we also already saying, okay, it kind of depends on PEP, which is mainly the protobuf descriptor, because when we have some models which do like a subsystem, which really helps you to send this protobuf data. Yeah, it's nicely gamed in the Zephyr doku. Zephyr doku is in generally not bad. Most of the things are actually quite good nowadays. It's just sometimes difficult to find the correct place. As you see in our protobuf, it's actually just saying, it's also a bit older when we start to write it. Nowadays, you can make it nicer with integration with nanopp, but as always, more projects on time. so it's still using a bit of an older approach, but you just added all the protobus files you wanted to include. Basically, we always say if you want to enable a config or not. So Kconfig is our friend, and even we can disable and enable certain sub features of it. As you can see, so the Kconfig is the magic behind it. So we started to move more and more things into the Kconfig. So sometimes I have a feeling of writing more Kconfig configuration files than code nowadays, but it helps with making things faster in the future. Basically what we are doing, we adding all the subdirectories as needed, and then, as I said, this is a bit older, there's actually better CMark markers now, but basically you can enable each subsystem. Sometimes it's more not linear in subsystem, sometimes it's just very sub features, and some of the things are not really developed anymore because we're not really working on some features anymore. Some of the stuff should probably also put on an upstream, but time is critical, and also the free time is even less if you're getting older. There we have a very simple one. So COPS is, I think it's nowadays there's even not a thing in Zephyr, but it's like a abstraction for a protocol encoding for which we use mainly for UART. So you see, even we have a copy paste error here. So yeah, but anyway, very simple ones is always like just the config, which you can enable, and we kind of define the logging system for it. So if you look into the subsystems in Zephyr, this is what you would at least always find. So this is the most basic one. When the things are getting more complex, then you have, for example, this is also something which is more now available in a standardized Zephyr way, but as we started, it was not available to manage secrets. And you don't only want to have the secrets running, in our Nordic system, but also in our POSIX system. So we had like one for the Nordic and one for the POSIX, and especially the one for the POSIX, we enabled all the MBTL features we need for this. So, and for the Nordic, we kind of then use the Nordic stuff to save it on the modem. And in the end, for the app, it's very easy to use because when you have one interface. Now with the PSR, it's even easier if you go from a new from a Zephyr, so you would probably use this one. And the same for the, as you can see, we detecting a train. Now it's also called activity detection because we said, hey, you can detect more than just a train. You could detect any sort of activity. But in the end, we supporting different MEM sensor for waking up. So with the ST1, another ST1, when we had one from, your naming is stupid because we have two different ones for analog devices. Then we have fake one, which is basically just generating randomly activity events. And then we have the POSIX ones, which is kind of just enabling a shell interface where you can say activity in 5 minutes or activity in 1 minute. And this is kind of how the fake one is running. The fake one is attended that you have some sort of long-term test and you just activated it and you want to see it generates in one. Yes. What does it mean to make it in a subsystem? One important thing we kind of figured out early, you don't want to write the boiler code in your main application. So use the sysinit feature of Zephyr to do all the initialization you need for it. If you have some execution, rule of thumb, at least for my feeling is, if it's very short and it's not a lot of complexity, you put it on a work queue, either it's event-driven or you have it delayed with a timer kinda. If it's getting more complex, move it to a thread, because especially if you start adding threads and you still have an embedded system, each thread takes memory and flash and you have less and less. We kind of also use quite a lot CBus to have like this event-driven system where we just generate events from one subsystem and the other ones can listen to it. Doesn't mean you have to use it, but I personally really love it. This boot, how it could look like. So we want that all our devices have the same boot messages. It's mainly because we also have a hardware and loop testing system, and our test engineers do not want to write a new test system for each different device. So it always looks the same. And then we said, okay, in the sysinit, when the device did boot, as the last thing you do before entering the main, just say, hey, I'm booting. This is my firmware information. This is my manufacturer product number, my PCB type, which is the sensor I am having. if I have a reboot cause enabled feature, even give me this, and then just say ready, and when we print this ready, the test system knows it can start. It just makes the life a bit easier. Same runs for POSIX, so which is nice. If the sim is a bit more complex, okay, it's a simple example, but in the state machine, a lot of things happening. Also, would be now more Zephyr systems which you could use, but when we started to write on it, there was not that nice feature support for the modem, how we want to use it. So we kind of have a modem state machine handle the different state of the modem, handling when the modem is crashing, handling the modem low power safe mode. The whole thing is also running in Zephyr, not in Zephyr, in POSIX. In the POSIX mode, it's just use a socket and then just say, I'm offline on a shell. So again, if you use a thread, you have to add stacks, and then you can again run out of memory. So then what we are happening quite often, we have, this is an example in our devices like collecting acceleration, but also quite common features. You want to have some diagnostic or telemetry about the device itself, which we are in our case doing like once a day. And so we just put it on the work queue, and once in a day we just kind of run this thing through. And this is basically getting how much did we consume energy in this last 24 hours, what's our voltage levels, some temperature, and some more events, and just kind of create this as a diagnostic at a message, put it on a archiver, and as soon as the device connects to the next time, we are sending it. And this is on a work queue, because then we can have lots of this kind of small items without adding significantly more memory consumption. You need a tiny bit of flash memory to adding this work queue items, but it's not as much as a thread. Yeah, config examples, you can make them more and more complex. So mainly they allow you, depending on your hardware, on your system, to define how much you can have. So we have some things which are, let's say, more device specific. So we are using lots of ABS, and we want to example when a device is produced, it only works in one region. So it's kind of already fixed flash firmware for one region and some more options. It's the same for the signing key, whereas like some public stuff is done via the config. Private stuff we don't do like this because we are hiding it in a secret storage management. And also just things which are more like not so important, like which bucket it ends. And we have a kind of a debug feature when you upload stuff that we print at certain percentage, how far it is. Normally we use 10% for our all the debug stuff, and it's the production one is basically just print at 50%. So it's kind of say it's somewhere, it's in the middle, and it's done. Also, what a lot of people talked about, the shell is so extremely helpful if you develop. And it doesn't care if it's POSIX or if it's U1, but we kind of at every bit more complex system we are doing adding shell features. And the shell features could just be if you have something like the modem where we have kind of a public RPE with functions you could call, we just expose all of them so you can call all the RPE functions. Helps a lot, just with local testing or our QR guys trying to stress test things and call the RPE in evil order. And in the end, our main looks a bit more complex than someone else's main, but kind of we have some initial state and initial event, which is system starting, and then we call our business logic. So in the end, it's a big state framework from the SVFM feature, and it's just, in our example of a train detected, is there a train detected? Yes, record the train, go back, and if a timer runs out, okay, try to transmit over trains. And some support features for production and other like storage mode where the device, if it's kind of off, and it should be in an extremely low power mode. Yeah. And what happens in the end, our project.conf is a lot of configs. And it's a bit always sometimes feels like a dependency hell, because sometimes you enable some config and something is not working. And Zephyr, it's also depending of your West manifest. It could be that you actually have features or subsystem you're needing, which are from main Zephyr, not in your allow list anymore in the default. So it especially can change with version changes. So we had that happen that things are running quite nicely. we went to a new main version of Zephyr, and things will stop working, and you have a lot of errors in the beginning in the config. And then you figure out, it's because I think it was even nanopp and some other modules are not anymore defaultly added into the Zephyr modules if you branch it, and then you have to add it in a allow list. But it makes it very nice, simple, when you figure all the stuff out to write new applications. As an example, we have a new prototype device for measuring angular movements, and it was 1 week of an electronic engineer kind of develop a new sensor board, which was not really 1 week of working for him, but like 2 days, 1 week finding the datasheet was correct 1 week of PCB, and then a few days just testing if it really works. And the firmware person writing it, the firmware guy, my colleague, he even decided, okay, I try to build the business logic in Rust, and he spent 1 month with this. Was the 1 month was mainly 3 weeks just understanding how the Rust subsystem works in Zephyr, and 1 week was getting it working. So, as I say, it's like in the middle. So I see it can be great, but it's not there yet. And the same the board. So we had for this main device already 3 PCB iterations. Now we had the final one 4. But you see, we started just with a dev board, adding all some sensors of it. This dev board was running in our system for integration test until 2 weeks ago, and then we ditched it, and now we are just using the newest PCB and the native sim, but we kind of had support for all our different PCBs in the system. And and for the POSIX one, we kind of just enable the fake sensors and have some config that we do not use any sort of downsampling, because we just use already prepared fake data to confirm that the logic runs as we want. A few things which I would do differently now if we start from again. So we would probably already use our internal Zephyr fork, because we upstreamed a few driver changes we wanted to do, and it was a bit annoying from our internal shared library to put it back to Zephyr, because when I had to do I done a local fork on my private time, copy pasted things, changed a few of the logic. So this would have saved me at least 1 day. And everything which is the Sailor more business critical, we put in a shared model. Also, we have also a few drivers which should not be on a Zephyr, because they are very tightly coupled to Nordic's DMR system, and they don't make sense to be shared. And I would also extend the West system nowadays. Instead, we have kind of our own scripts, which when calling the West, which is a bit of an overkill. But as we started, we had already kind of the system existing, and then we kind of plugged West on top of it. But that's just, after working with it. So, and should be exactly on the time we had. And as Zephyr is basically loves kites, I think there was someone still there to get it. So, so get some kites. They are blue in that multicolor. Any questions? Yes.
Yeah. So with a highly Kconfig driven example, it looks very with big fan of that. But do you, in your testing, you run the all mod config script from the Kconfig library? See, the reason I ask is I'm not sure whether it's done in separate CI. There is a script that comes with Kconfig lib called all mod config. And what it will do is it'll iterate through your Kconfig tree and set everything to yes. Everything that you can set to yes.
I didn't know it. I will remember it and add it in our idea. Thank you.
And so last thing, the ZBus thing, it's amazing. It's really good.
Yeah. So my opinion. Cool. Yes, in the back.
We showed it 2 slides or so. The mechanism how you implement the logging for your subsystem. It's using a Kconfig template, which is quite nice, because then everything looks the same in the menu config. Did you start writing your own Kconfig templates for your configuration setups, or is it?
It's a Zephyr one. It's.
Oh no, I know that the Kconfig template you use there is from Zephyr.
Oh yeah.
But do you also write your own templates for unifying your configuration setups, or?
it's on the list of things we want to look into. So yeah, we didn't do it yet, as we are currently in a phase of the project is getting to manufacturing, so it's less work on the software engineers, but more on the hardware engineers. So now the software engineers have some time to clean up their mess.
Nice.
Yeah. Nothing else? Cool. Otherwise, you can catch me or ask me any questions, or as I'm around for Munich, if you live in Munich, you can invite me for a nice coffee or speed tea, and we can nerd out about Zephyr.